Increasing and decreasing functions. Theorem 1. Let f be continuous on closed interval AB and differentiable on open interval AB. Then f is increasing in closed interval AB if f dash x is greater than 0 for every x belongs to open interval AB. F is decreasing in closed interval AB if f dash x is less than 0 for each x belongs to open interval AB. F is a constant function in closed interval AB if f dash x equal to 0 for each x belongs to open interval AB. So this is basic definition or basic theorem that tells how one can classify whether function is increasing or decreasing. So for this, we have to find out first derivative and then we have to check its sign. If it is positive, in that case, it will be increasing. If it is negative, then it will be decreasing. And if it is 0, then it is a constant function. Let's see this graph. If graph is going like this, what can you say about the function? It is increasing. Of course, if you take one value of x here, then if you take another value of x here, as you increase the value of x, the value of fx will also increase. So its derivative will be positive. If function is like this, suppose it moves like this, then it remains constant, and then again it moves like this. It is also increasing. So what is difference between these two functions? This is increasing. This is strictly increasing. What about this function? It is strictly decreasing. And there is another function. Suppose it is coming like this, then it goes like this, then again it goes like this. So it is decreasing. So this is strictly decreasing. This is decreasing. Now let's understand this concept by some examples. Question number 1. Prove that the function given by fx equal to 7x minus 3 is increasing on R. So fx equals 7x minus 3. We find its derivative f dash x equal to 7, which is greater than 0. Hence, function is f is increasing. If you see the definition, it says f is increasing in closed interval AB if f dash x is greater than 0. And here we have got f dash x as 7, which is greater than 0. So function is increasing. Now take another example. Prove that the function f given by fx equal to x cubed minus 3x squared plus 4x, where x belongs to R, is increasing on R. So fx equal to x cubed minus 3x squared plus 4x, f dash x. So it will become 3x squared minus 6x plus 4. Now we have to check whether this is greater than 0 or not. So what we do, we make it perfect square. We can take common 3 from these two terms. So it will become x squared minus 2x plus 4. Now what we can do, we can add 1 inside the bracket, so 2x plus 1. And when we multiply this 3 to 1, we get plus 3. So we can subtract minus 3 here plus 4. Total effect is same. If you open the bracket, 3x squared minus 6x plus 3 minus 3. Now 3, this will become x minus 1 whole square plus 1. Clearly, this can't be negative. This is also non-negative term. So it will be greater than 0. Hence, we can say the given function fx equal to x cubed minus 3x squared plus 4x is increasing on R. Let's take next question. Show that the function given by fx equal to cos x is decreasing in 0 to pi, increasing in pi to 2 pi, and neither increasing nor decreasing in 0 to 2 pi. Let's see. Here we are given fx equal to cos x. Now f dash x will give minus sin x. F dash x equal to minus sin x. Now we have to check the sign of f dash x in these intervals. So if you remember the graph of sin x, it goes like this. So this is pi by 2. This point is pi. This point would be 3 pi by 2. This will be 2 pi. Now, here the given interval 0 to pi. So this is sin x. So sin x from 0 to pi, it is positive. So if it is positive, then f dash x will be negative. So f dash x will be sin x is positive. From here it is clear. So we are considering this interval 0 to pi. So 0 to pi. So in this interval f dash x, since sin x is positive, so this minus sign will make it negative. Hence we can say that f dash x is less than 2. So function is decreasing in this interval. It is decreasing. Now, second interval is pi to 2 pi. If you observe from here to here, sine x is negative. So if sine x is negative and there is already minus sign, then it will become positive. So in interval pi to 2 pi, f dash x will be minus sine x, which will be greater than 0. As I told you, in this interval, you see that graph is negative. So if sine x is negative and there is already minus sign, so total result will be positive. Hence, it is increasing. Now, if we consider from 0 to 2 pi, so once function decreases, then increases. So we say that in interval 0 to 2 pi, function is neither increasing nor decreasing. Now, let's go to next question. Find the intervals in which the function f given by fx equal to x square minus 4x plus 6 is increasing or decreasing. So let's see. Fx equal to x square minus 4x plus 6. We find f dash x. So it will be 2x minus 4. We put f dash x equal to 0, from where we get 2x minus 4 equals 0 or x equal to 2. We draw a number line. We locate x equal to 2 here. Then here it will be minus infinity and it will be plus infinity. Now, let's see. We take interval. So here we can make a table. Here we write interval. Then we write sine of f dash x and then nature. Let's see first interval minus infinity to 2. If we choose any number between minus infinity to 2, suppose we take value here, x equal to 1. If we write x equal to 1 here, then it will be negative. So f dash x will be less than 0. Hence it is decreasing. Now, if we choose this interval, so 2 to infinity, suppose we take this time x equal to 3. If we put 3 here, 3 to the 6 minus 4, which will be positive. So f dash x will be greater than 0. Hence function is increasing. So here our question was to find out the interval where function is increasing and it is decreasing. So in the interval 2 to infinity, function is increasing. In the interval minus infinity to, it is decreasing. Let's take next question. Find the intervals in which the function f given by fx equal to 4x cubed minus 6x squared minus 72x plus 30 is increasing, b part decreasing. Let's see the solution. Fx is given by 4x cubed minus 6x squared minus 72x plus 30. F dash x will be 12x squared minus 12x minus 72. So we can take common 12x squared minus x minus 6. We put f dash x equals 0. That is x squared minus x minus 6 equal to 0. And this will give x minus 3 into x plus 2 equal to 0, from where x equal to 3 and minus 2. So we draw a number line here. So minus infinity to minus 2, then minus 2 to 3, and then 3 to infinity. So there are three intervals. So here in these intervals, we have to find out the sign of f dash x. So we can make a table. Intervals. A sign of f dash x and nature. So first interval is minus infinity to minus 2. If we choose some values between minus 2 to minus infinity, suppose we take x equal to minus 3, and we put this value here, x equal to minus 3, then what will happen? This will become minus 6 and this will become minus 1. So both will be negative. So negative times negative will become positive. So it will be positive, and it means it is increasing. Now we consider interval minus 2 to 3. Minus 2 to 3. Suppose we take x equal to 1. If we write here x equal to 1, so this will become negative. If there is doubt, we can write it here, x minus 3, x plus 2. And when we put x equal to 1, so this will become negative and this will become positive. So total multiplication will be negative. So it is negative. It means function is decreasing. Now consider next interval 3 to infinity. So suppose we take x equal to 4. When we write x equal to 4 here, this will become positive, this will become positive. So overall it will be positive. So function is increasing. Now consider next question. Next question is, find the interval in which the function given by fx equal to sine 3x when x belongs to 0 to pi by 2 is increasing or decreasing. Okay, so let's consider its solution. Fx equal to sine 3x. Now f dash x will become 3 cos 3x. So we put it equal to 0. F dash x equal to 0. That is 3 cos 3x equal to 0, which gives cos 3x equal to 0. Now, if we consider the graph of cos x, so graph of cos x is like this. So here, this value will be pi by 2, and this value will be 0. This value will be pi, and this will be 3 pi by 2. This will be 2 pi. Now this is graph of y equal to cos x. Here we are given y equal to cos 3x. So in that case, here this is graph of y equal to cos x. If we plot the graph of y equal to cos 3x, then graph will remain same except the values, these values will be divided by 3. So this point will become pi by 6. This point will become pi by 3. This point will become 3 pi by 2 divided by 3, that is pi by 2. This point will become 2 pi by 3, etc. And this point will remain 0. Now here graph is taking value 0 at pi by 6 and at pi by 2. Here our interval is given as 0 to pi by 2. So we can say that x equal to, here either we write 3x equal to pi by 2, from here 3x is 0 means cos x is 0, pi by 2 3 pi by 2, but our range is in the question 0 to pi by 2 only, so we cannot take this value 3 pi by 2. So we consider this graph for cos 3x values where the graph is taking value 0, so it is pi by 6 and pi by 2. So we can say interval will be x will be pi by 6 and pi by 2. Is it clear? So here it is pi by 2 and it is pi by 6. So we have got the interval where value of cos 3x is 0. So we can divide it like this. So given range is 0 to pi by 2. So suppose this value is 0. So we start from here. Then next value is pi by 6. Then next value is pi by 2. So we have to restrict ourselves in these intervals. So let's check the sign of the function in these intervals. So for this purpose, we make a table and we write the intervals, and then we check whether function is increasing or decreasing. So interval sine of f dash x and nature. Let's see. So interval we consider 0 to pi by 6. Now in this interval, so we have to find out the nature of this function. So we can see by the graph, it will be easier. So this point is pi by 6. This point is pi by 2 for graph y equal to cos 3x. So we are considering interval 0 to pi by 6. So in this interval, it is clear that cos 3x is 0. Cos 3x is positive. So this term will be positive. So we can say f dash x will be greater than 0. So function will be increasing. Now let's consider next interval pi by 6 to pi by 2. So here it is pi by 6, it is pi by 2. During this interval, cos 3x is negative. This is negative, this is positive. So if cos 3x is negative, then f dash x will be negative. So interval pi by 6 to pi by 2, f dash x will be less than 0. Hence function is decreasing. So I think you must have understood. Thank you for watching.